I did the swashbuckler, and the ride was based off of circular motion and centripetal force. I used Newton's second law to solve for the friction force and to break the gravitational force into components because it was on an angle. Also, there was two normal forces, but the normal force from the ground up was negligible because during the ride, that's one of the thrills that you don't really have your feet touch the ground. And for the percent error with centripetal acceleration, there is a 76% error, and I got that the theoretical acceleration was a lot greater than calculated acceleration, and that was probably due to human error and the fact that kids probably didn't know what time to start measuring, or they had a different interpretation of when it was at full speed or from rest to full speed, so that could account for the errors. For the number of G's, it was way less than 4 to 6 G's, so the ride was obviously safe and no one was going to black out. And some of our calculations showed that the number of G's was around 1 or less than 1. So that gave the experience of feeling weightless, especially at the top of the angle on the ride, more so than at the bottom. You felt the normal force most when you're on the bottom of the ride, at the bottom of the angle. And so that was the greatest apparent weight. When you're at the top, you felt more weightless. So that contributed also to the thrill. You felt the most force factor on the bottom because you're being pressed against and you're feeling the most force of gravity than at the top. I also used the law of conservation of energy to find the work done by the ride so that I could find the power overall. And this was considered centripetal acceleration because the ride was increasing speed until it got to max speed, but then it went at constant speed, though it was still acceleration because the direction was constantly changing. I used the linear velocity and angular velocity to help find other values. And that's a swashbuckler. Bye!